The year was 1600, Campo de' Fori in Rome. A man named Giordano Bruno, an Italian revolutionary philosopher and friar, was burned alive. Want to know why? To understand that, we have to go back to 1584, to London, England, where this same Italian revolutionary philosopher and friar Giordano Bruno published a book titled Del Infinito Universo e Mondi, on the infinite universe and worlds. In this thesis, Bruno challenged the established beliefs of his time, arguing that our universe is infinite, that it has no center and no final boundary or wall. Bruno believed the stars visible at night were actually suns like our own, each with Earth-like planets orbiting around them. In that era, the reaction to this idea was brutally violent. The Roman Catholic Church branded it heresy. The Church held that God's creation was finite and that Earth sat at its center. Bruno refused to back down. As a result, in 1600, he was burned alive in a public square in Rome. But the spark Bruno had lit, the idea of an infinite universe, was one science could never put out. Centuries after Bruno, once modern quantum physics was born, scientists began mathematically measuring the boundaries of the universe. On April 30, 1983, Professor Alexander Vilenkin of Tufts University in the United States published a genuinely startling research paper in the prestigious journal Physical Review, titled Creation of Universes from Nothing. Using the mathematics of cosmic inflation, Vilenkin proposed that our universe is essentially a bubble. He argued that new universes, called pocket universes, are constantly being born throughout space. We exist inside one such giant bubble, and beyond it lies a hyperspace where the laws of physics change completely or simply cease to exist. When Vilenkin's theory emerged, it sent shockwaves through the scientific community. Great physicists from Stephen Hawking to Alan Guth engaged in lengthy debates over it. At first, people tried to dismiss it as pure science fiction, since directly observing it was impossible. But today, the theory of eternal inflation and the multiverse is considered one of the strongest models in modern cosmology.
But an even bigger bombshell landed in 2008, when scientists thought they had actually detected the effect of an invisible wall at the edge of the universe. Astronomer Michael Hudson of the University of Waterloo in Canada, along with his colleagues, published a paper in the monthly notices of the Royal Astronomical Society. Studying the cosmic microwave background radiation, they found that hundreds of galaxies were being pulled rapidly in one particular direction, towards some unknown and immensely powerful force. This phenomenon came to be known in the scientific world as dark flow. It seemed as though something colossal existed just beyond the edge of the observable universe, a kind of cosmic wall, or perhaps another universe pulling our galaxies toward it. This discovery frightened the general public and thrilled scientists in equal measure. Headlines began appearing claiming that the wall of the universe had been found. Still, opinion within the scientific community was deeply divided. Later data from NASA's Planck satellite cast doubt on the claim, with scientists suggesting it might not be a solid wall at all, but rather a gravitational illusion arising from irregularities in the universe's earliest moments. But these three discoveries, whether Bruno's infinite universe, Vilenkin's bubble, or Hudson's dark flow, all made one thing clear. Every time human civilization has tried to touch the edge of the universe, science has had to redraw its own boundaries. If these real struggles of scientists and the deep mysteries of the cosmos fascinate you, stick with this video till the end and consider hyping it up or grabbing a membership, because we're about to head toward that modern boundary today's science calls the observable universe. What shape do you think our universe actually is? Drop your thoughts in the comments. When scientists talk about the universe, they actually mean two different things. First, the observable universe, the part we can actually see, and second, the entire universe, which likely lies far beyond our reach. To understand the observable universe, we need to grasp one of physics' most fundamental rules, the speed of light. Light is the fastest thing in the universe, covering roughly 300,000 kilometers every single second. Now here's a paradox worth pausing on. Our universe is about 13.8 billion years old, so logically, we should only be able to see light from up to 13.8 billion light-years away, right? But when scientists actually measure the diameter of the observable universe, the figure that comes out is roughly 93 billion light-years. How is that even possible? How does a 13.8 billion-year-old universe end up spanning 93 billion light-years?
This is the universe's greatest piece of magic. As light from the universe's earliest moments has been traveling toward us, space itself has also been expanding. Think of it like walking along a rubber band while someone stretches it from behind. The distance you actually cover ends up being far greater than your own walking speed. Or take another example. Mark a few dots close together on a deflated balloon, then start blowing air into it. As you inflate the balloon, the distance between those dots keeps growing, even though the dots themselves never move relative to the balloon's surface. This is exactly why a limit forms, one we call the cosmic horizon, the absolute edge of what we can ever see. Light from beyond that horizon hasn't reached us yet, and likely never will, because that region is now retreating from us faster than light itself. So, does that mean there's simply nothing beyond this 93 billion light-year bubble? Or is there some kind of boundary out there? Let's find out by taking an imaginary journey of our own. Buckle up, we've just launched from Earth. In the blink of an eye, we clear our solar system. The reach of our sun's light now looks like a mere speck behind us. We push on further, and our own galaxy, the Milky Way, comes into view. A vast spiral structure of 200 billion stars that looks infinite up close, yet it's left behind in mere seconds of our journey. Now we're in the local group, a small family of roughly 54 galaxies that includes our neighbor Andromeda. The distances have grown so vast by now that the emptiness between the stars starts to feel unsettling. But hold on, our journey has only just begun. We're entering the Virgo Supercluster, and beyond that, the grand structure of the universe that leaves the human mind stunned, the Laniakea Supercluster. Laniakea means immeasurable heaven, and it holds over 100,000 galaxies bound together. Push past even that, and we arrive at the cosmic web, the skeleton of the universe, where galaxies, gas, and dark matter are strung together along long filaments, with voids millions of light-years wide stretched between them. Vast emptiness where there's nothing at all. No star, no planet, just pure darkness. And no, these aren't black holes. Now we're closing in on the final edge of the observable universe, the cosmic horizon, 46.5 billion light-years out. Here, everything around us starts to shift. The universe behind us fades into a blur, and ahead lies nothing but infinite, unknown emptiness. We now stand at the threshold of the universe, a point human thought itself has never reached. Will we crash into some kind of wall here? Will space and time simply cease to exist beyond this point?
To answer that, modern astronomy and theoretical physics offer 5 major theories. Let's try to make sense of them. The first and simplest theory holds that the universe has no boundary at all, that it's infinite in every direction. That means if you kept traveling past the edge of our observable universe, you'd simply find more galaxies, more stars, and more emptiness endlessly. But this theory has a strange implication. If the universe is truly infinite, every possible arrangement of matter must repeat infinitely as well, meaning somewhere out there in that infinity, there's an exact duplicate of Earth with someone identical to you watching this exact video right now. Essentially, the multiverse theory. The second theory is called infinite but bounded. It's a bit tricky, but important to understand. According to Einstein's general theory of relativity, space itself can curve. Consider this example. Earth's surface is finite, but does it have any edge or wall? No. You can keep walking on it forever and eventually circle back to where you started. Scientists believe our universe might not be three-dimensional, but rather a four-dimensional hypersphere, meaning if you traveled in a straight line long enough without ever hitting a wall, you'd eventually arrive right back at Earth billions of years later.
much like sailing across the ocean. Keep going in one direction long enough, and eventually you return to your starting point. This very principle is what first told us Earth is round. The biggest factor in determining the universe's shape and its ultimate fate is its density. Cosmologists describe a few possible types of universe. A closed universe, shaped like a sphere, would eventually collapse back in on itself, returning to the very state the Big Bang first emerged from. An open universe, shaped like a saddle, would keep expanding forever without end. A flat universe, shaped like a flat sheet, sits at a critical balance, steady expansion that eventually slows and stops. Current scientific data, particularly from studies of the cosmic microwave background by the Planck satellite, shows with over 99% precision that our universe is flat. But what does a flat, sheet-like structure actually mean? Would it have an edge? Science says this flat universe could still be infinite, but the story doesn't end there. Behind this flatness lies an enormous force that has completely reshaped the boundaries of how the universe might end: cosmic inflation, an almost unimaginable expansion.
In 1980, American physicist Alan Guth proposed a groundbreaking theory called cosmic inflation. According to this theory, in an unimaginably tiny fraction of a second right after the Big Bang, a billionth of a second or even smaller, the universe underwent an explosive event that stretched space out at many times the speed of light. Now, how can anything expand faster than light? Einstein said no object within space can travel faster than light, but space itself can expand at any speed it likes. What do you think might lie beyond this unimaginable expansion? Share your thoughts in the comments. Guth's inflation theory proved that the observable universe we see today is actually just an incredibly tiny fraction, perhaps just a sample, of the entire universe. The real universe is so much larger than this 93 billion light-year boundary that the human mind simply can't process the numbers involved. So then, what's all this talk that keeps circulating online? Have scientists really found a wall out in space? Does an actual cosmic wall exist? Whenever you read articles or watch videos about space, you often come across terms like cosmic wall or the wall of the universe. Are these the very walls that mark the end of the universe? Science has a clear answer here. When scientists mapped out the universe, they did find some astonishingly massive structures made of galaxies. The Sloan Great Wall is one such wall-like structure of galaxies, stretching roughly 1.37 billion light-years, so vast it spans roughly 10% of our entire observable universe. But keep in mind, neither of these is a physical wall stopping the universe from extending further. They're simply enormous superclusters of billions of galaxies drawn together by gravity. Space on the far side of them looks exactly the same as it does on this side. So if these great walls aren't the actual edge of the universe, then what really lies beyond it? Let's assume, just for a moment, that the universe does have a boundary. What might exist beyond it from a scientific standpoint? Here, we step outside established science and into the realm of theoretical hypotheses, meaning we don't have direct evidence for any of this, but there are theories we find compelling. Nothing. This might sound strange, but nothing here doesn't mean empty space. Even empty space still has time and quantum fluctuations happening within it. Nothing beyond the universe would mean no time, no space, no physical laws whatsoever. Not even the concept of zero would exist. The second theory is the multiverse and bubble universes. According to quantum mechanics and string theory, our universe isn't alone. Just as countless bubbles rise in boiling water, countless universes are constantly forming within an infinite hyperspace. Each bubble may carry its own physics, its own laws, and its own boundaries. The third theory is brane cosmology. This theory proposes that our universe is a three-dimensional membrane or brane floating within some higher dimensional space, much like a sheet of paper hanging in a room.
Scientifically speaking, all of these theories currently rest purely on mathematical equations. We have no direct physical proof for any of them, but they certainly make us think. If you actually reached that edge, what would you experience? Let's return for a moment to that extreme thought experiment. If you somehow found yourself standing at the very edge of the universe, what would your eyes actually see? According to the laws of relativity, as you approach that boundary, one expanding at the speed of light, time would essentially stop for you. Looking back, you'd see the entire history of the universe compressed into a single second. And looking forward, in the total absence of light, you'd find nothing but complete, absolute darkness. The geometry of space-time itself would simply end there. You'd be standing at a point where every equation of physics divides by zero, infinity itself, a point where science falls silent. What is the ultimate fate of the universe? The universe's end won't happen only in space, it will happen in time as well. Astronomers have laid out a few unsettling scenarios for how it could all end. Heat death. The universe keeps expanding forever, stars burn through their fuel, black holes eventually evaporate, and in the end, the entire universe turns into a cold, dead, endless darkness. The Big Rip. Dark energy grows so powerful that it eventually tears apart galaxies, planets, and ultimately even atoms themselves. A cyclic universe. The universe's end, a big crunch, becomes the starting point of a brand new Big Bang, an endless cycle where the death of one universe gives birth to another. After this entire journey, once we finally return to Earth, a deep philosophical truth confronts us. Can our limited human minds, shaped entirely by Earth's own rules, ever truly grasp this kind of infinity? Perhaps this restlessness, this urge to find the edge of the universe, is exactly what gives meaning to being human. We are smaller than a single speck of dust within this vast universe, and I'm not just talking about you and me, I'm talking about our entire solar system. And yet, the curiosity within us is larger than this entire universe itself. According to current science, the universe has no physical wall. What feels infinite to us is really just the limit of what we can see, our own cosmic horizon. So, in the end, this question is left for you to ponder. If this universe truly has no boundary, if it really is infinite, then within that infinity, just how much do our joys, our sorrows, and our own existence really matter? And if science ever proves one day that the universe does have a boundary, a final wall, just imagine what might lie on the other side of it. If this journey through the mysteries of the universe excited you, and you'd like to see more in-depth documentaries on deep scientific topics like this video, subscribe to the channel, and be sure to share it with your friends. Feel free to hype it up. And if you'd like to grab a channel membership, that helps us too. It lets us keep bringing you better content. See you on the next journey. Until then, keep exploring, because science never stops.